This video is for Chapter 10, Section 10.3 for the math activity Views of Cube Figures. We'll explore these space figures, we'll build figures, and we'll draw views of cube figures. We'll need cubes and grid paper. You can find grid paper at our website, and if you need remote access cubes, try the National Council of Teachers of Math, NCTM, Isometric drawing tool. This is linked below this video. You can drag cubes into an isometric grid and rotate them. In question 1, we have a cube figure made of 5 cubes. You can see 4 and there's 1 in the back there holding up that cube at the top. You can look at this figure from the top, the front, and the right side. Notice in the front you have a cube that's marked with red. We have a top view, a front view, and a side view of this cube figure. Here's a little more detail. Here's the top view, and you can see that I've marked here, the numbers are just for clarity for this discussion, 1, 2, 3, 4, 1, 2, 3, 4. Here's the front view, and you can see here I've marked 1, 2, 3, 4, 1, 2, 3, 4. Again, the numbers here don't mean anything, they're just for demonstration. And then finally the side view, which is the right side view. If I'm looking here and I'm thinking of flattening my figure onto a plane back here, I see 1, 2, 3. There's my side view. So for question 1, we'd like you to build each of these figures and then sketch the top, right, and side view. You'll need grid paper for that. And the only hidden cubes are those that are supporting other cubes. So for example, in C, there are hidden cubes in the back to support these stacks of cubes. In part A and B, you can see all the cubes. In question 2, a blueprint for a cube figure can be made by showing the top view and writing a number in each square to indicate the number of cubes in the column of that cube figure. For example, a cube figure and its blueprint are shown here. So here's the cube figure and here's the blueprint. This is a top view, and the numbers of the figure below here are marked to match this blueprint for your information. So this has 2, so that's the 2, 1, 1, 1, 1, 1, 1, and this has a stack of 3 cubes, so that's 3. Here the numbers mean something. So in question 2, we give you 3 cube figures and ask you to write the blueprint for each figure. And again, the only hidden cubes are the ones that support the other cubes. And think of using individual cubes here. They can't hover in space. In question 3, we give you the top, front, and side view of cube figures. And you are challenged to use the fewest number of cubes possible to construct the figure that would have this top, front, and side view. Sketch a blueprint and give the total number of cubes. And again, you want to use regular cubes here. Nothing can hover in space. In question 4, we remind you that in activity 2, we define the term blueprint for the top view of a cube figure. And we ask you, why does this give more information than defining the blueprint for either the front or the side view? So think about making a blueprint with the front and the side view, or the side view, and see if you can build the cube figure from that. And this should help you answer part A here in question 4. In part B, if 2 people were each given a blueprint for a cube, one from the top view, we ask, would it be possible for each person to correctly build a corresponding cube figure and have 2 different cube figures? And you should illustrate your reasoning with examples. Now notice that if you have children doing a similar activity and they're using linking cubes like this, they might have a different approach because linking cubes can hover in space and they don't need supporting cubes. You can explore this as you answer question 4B. I hope you have fun with Math Activity 10.3. It's really quite interesting to build cube figures and think about all the projections and different views.